I'd like to welcome you to this Kubernetes by example course on Spring Boot Microservices running inside of Kubernetes. So Kubernetes gives us a lot of capabilities, and in this course we're going to look at a more realistic example. So I've created some Spring Boot Microservices mimicking a brewery, so fun topic. And what we're going to do is take these three microservices, which need a MySQL database for their persistence. They also communicate using JMS. And a little icing on the cake, we are going to be doing consolidated logging using Filebeat, Elasticsearch, and Kibana to actually view the log data. So we are going to be taking this application and getting it all set up in a Kubernetes environment. So I think this is going to be a really good course to go through because we have a very realistic example of multiple microservices that need support services, that need consolidated logging, and we are going to be going through that and setting up all of this in Kubernetes. So there's a fair amount of moving parts here, but I think this is a very realistic, real-world example of multiple microservices being managed by Kubernetes. So a lot of good content. First thing we need to do is go through some general housekeeping, make sure that you have your environment set up properly. So we will cover that in this course, and then in the next sections of the course we will be tackling the deployment of Spring Boot microservices into Kubernetes. In this video, we're going to talk about setting up your development environment. So for Java development, we're going to need any operating system, which is probably an operating system that you are using, Mac OS, Windows, Linux. I'm saying 8 gig of memory is probably the minimum. 16 gig or more is probably preferred just because of the nature of running Java and our IDEs and whatnot. They do tend to take up a good bit of memory. We will be using Java 11 or higher. You can use the official Oracle Java or OpenJDK, that is up to you, but be sure to have JDK installed. Docker Engine 2.0.10 or 0 or higher is what I'm recommending for the course. And then as far as build tools, if we get into those, we'll be using Maven version 3.6.0 or higher. Ideally, you want that installed for command line use. If you have any questions about that, see the official Apache Maven documentation. They do a pretty good job of explaining that, and it does vary depending on what operating system you are using. So verify your environment. Make sure that Java is installed. You can do that with Java minus version. Make sure the JDK is installed. I see that happen sometimes where you install the incorrect flavor of Java and get a JRE rather than a JDK. And to verify that, you can use Java C version. That tells you that the Java compiler is there, therefore you have the JDK. Maven, from the command line, ideally you'll be able to run mvn-v to show the version. And then Docker, of course, we want to see Docker PS. In the source code examples, I will be using IntelliJ Ultimate. This is a paid product, but it is not required. I'm using anything that we build is going to be used through Maven. That is a build tool which is supported by free IDE options such as STS, Eclipse, and NetBeans. So those all support Maven. Maven can also be solely used from the command line. So you could use just a text editor and the command line and you would be just fine. So IntelliJ definitely is not required for the course. Kubernetes, as we get into the Kubernetes content, you are going to need access to a Kubernetes cluster. Now, online, you can use the OpenShift Playground. Just Google OpenShift Playground. It'll take you right to it. You can get a free hour within a Kubernetes cluster to do what you would like. I will be running locally. So if you've installed Docker Desktop, I am running Mac OS, and I have installed that. You can simply enable that. So via Docker Desktop, this is probably going to be the easiest option if you have Docker Desktop installed. And then Minikube is a VM based that is available for most major operating systems. Or Kind, this is another project and that is Docker based. And depending on how you set things up, you do want to have kube control configured to connect to your cluster options. So depending on how you've decided to run your cluster, that is going to be one option that you can utilize. Okay, in this video, we are going to go through as far as setting up Kubernetes using Docker Desktop. So to do so, this is only if you're running Docker Desktop. come into Preferences for Docker Desktop, and you can see here I am using the Mac OS version. There's a tab for Kubernetes. If you're using Windows, it can be fairly similar to this. All we have to do is come over here and enable Kubernetes. And you can see here, show system containers. We don't need to see those, so this is automatically going to hide these. So Docker Desktop does work similar. It does bring up a single node Kubernetes, air quotes, cluster. Single node cluster seems like a contradiction in terms to me, but it will bring up a single node cluster. All we have to do is say apply and restart. And we can see that it takes a few minutes. That's because it's probably going to bring down some containers for this to support the cluster. And this will get Kubernetes on our system. And again, if you're running Docker Desktop, this is probably the easiest path to go as far as getting a local Kubernetes system running on your system. If you are not, I listed out a couple options previously, but to continue with the course, we will need Kubernetes up and running on your system. Okay, it took a few minutes for everything to get started. You can see here that I've enabled it. You'll see a progress bar while it starts up. And I did not take the option to show system containers. So you can't see them, and they're not going to be listed under everything. So if I come back over here to the command line, even if I do Docker PS, you can see that I have Postgres and Admin. These are two containers that I have up running, but we don't see anything for Kubernetes. But we do know from the UI that we expect that it is up and running. So let's come over to the command line. And if I do kube control, that's a git nodes. You can see that it's prompting me for a username. It should not be doing that. So I'm going to control C out of that. And if I had some other version, such as Minikube installed at one time, I might have to go ahead and set it to use the desktop version. And so what we can do is kube control, config, get context. Can see that I do have another one there. So at some point in time, it looks like the second one was created there. We want the Docker Desktop. So what I want to do is tell it to use that. And depending on how you set things up, you might not have to do this step. But I've done quite a bit of development on this machine over the years. I want to say kube control config, use context, like so. So we switch the context in the kube control and clear this. Now we should be able to use kube control get nodes. And you can see that we did connect to the Docker Desktop Kubernetes cluster and it says that we are ready. And we're not really running much right now, so not much to see. But we are able to connect to the Docker Desktop Kubernetes single node cluster. Okay, in this course we are going to be looking at four Spring Boot microservices that work in orchestration to create like a brewery. So we can view beers, add beers, delete beers, get beer inventory, we can brew beer, so that can place beer order. So a number of things that we can do. These are all REST APIs, but there's three specific microservices written in Spring Boot. This is stuff that I developed for a Spring Boot microservices course. So there's a lot that goes on in these services. So these are fully featured services. In this section of the course, we're going to take a look at what these services are, give you a good overview, do a source code review so that you can see and understand the Spring Boot microservices. So remember, this course isn't on developing Spring Boot applications. I got lots of other courses on those. This is specifically taking these Spring Boot applications and deploying them on Kubernetes. And in this section of the course, we are going to get you up to speed on the fundamentals of these microservices that I've developed and that we will be working with in this course. So I'll be showing you complete source code access, so you can dig into that as much as you want. But these are some really good examples. I chose these services because it does give us a really good example of deploying multiple microservices to Kubernetes, services that do talk and communicate with each other. So you'll see that in this section of the course as we go through the code review and how these different components components work together. So again, this is code that I developed for another course that I've adopted for this course because I think it's a really good example to use these for deploying in a Kubernetes environment. Okay, in this video, we're going to be talking about an overview of the Spring Boot microservices that we are going to be using for our Kubernetes by example course. So these are, I have 3 Spring Boot microservices. I originally developed these for my course up on Udemy, Spring Boot Microservices with Spring Cloud for Beginner Guru. I know, kind of a mouthful for the course title there, but it does cover specifically the development of microservices using Spring Boot and also a number of features specifically of Spring Cloud. We're not going to be using everything in that, so we are modifying these. This is the basis of these services. The services themselves mimic the operation of a brewery. So kind of a neat little project that we have here to work with. Data is going to be persisted to a MySQL database using JPA, Hibernate as the implementation, and then we're going to be using JMS for messaging between the services. So let's take a closer look at these 3 services that we have in play here. The beer inventory service. So this is going to be holding information about inventory levels. So this is going to expose a REST API to get inventory information. And then the service also uses JMS messaging. So we are increasing inventory from being notified of a brewing operation. So if we brew beer, inventory goes up. Then we decrease inventory from orders being allocated. And again, these are 2 different JMS messages that the services consumes. The beer service itself, that is going to hold information about the different beers that our brewery, air quotes, is brewing. It expose a REST API for CRUD operation against different beers that we are holding within our system. We are using JMS messaging to say, hey, we brewed beers to increase inventory. That sends out a message consumed by the inventory service to increase inventory. And then we also have a scheduled job that wakes up, checks the inventory balances, and creates brewing jobs, air quotes, to increase inventory. Now, next is the beer order service. This is going to hold information about beer orders. Again, it's going to provide a REST API about order operations. And then also, this is going to be using JMS messaging to, air quotes, allocate beer orders. This has a very important service called the tasting room service. This is a scheduled job to order beers from our tasting room at our hypothetical brewery. This, of course, is going to drive down inventory. As inventory goes down, we trigger brewing to increase inventory. So the key takeaway I want you to have here is that the beer order service is generating orders. This creates demand in the system. So this demand is requesting allocations from the inventory service, which is in turn reducing inventory. This triggers the beer service to, air quotes, brew beer, adding to inventory. So what this gives us is seeing the trio of services working in conjunction because we do have the REST APIs involved, as well as the JMS messaging. We can see and monitor log traffic to actually see activity in the system. So that tasting room service, real key takeaway I want you to have here is the tasting room service, which is within the beer order service, is creating demand on the system, which is going to get all the trio of services working together. Very important concept here. Now, finally, the inventory failover service. This is a failover common microservice pattern to provide a failover. So if things go away, in our hypothetical situation here, we wanted to always have, air quotes, inventory. So if our inventory service goes down, the inventory failover service is always going to return an on-hand quantity of 999. So this just gives us a positive value of inventory. In our hypothetical situation here, we want to always be able to serve as an order. So if we need an order, we want to be showing that there is on-hand inventory available. So in the original configuration, this was designed for a non-Kubernetes environment, kind of a generic environment that we set up. We are using Spring Cloud Gateway in front of the services, Eureka for service discovery, Spring Cloud Config for configuration services. And then we can see that the 3 services are deployed, each with their own MySQL backend, and then also ActiveMQ for our JMS broker. And then, of course, we have our inventory failover service, which is completely standalone. It doesn't have a database. It just needs to provide back a positive response. Now, some of the changes that we are making For a Kubernetes environment, we're not going to be using Eureka. Kubernetes is going to be using for service discovery, so we are removing that from the old config. Spring Cloud config, we're also not using that. We're going to use Kubernetes to manage these environment properties. Then I'm also going to be moving the services to use a single MySQL instance. This is really just for simplicity. The focus on this course is actually deploying on Kubernetes itself. We're not talking about constructing Spring Boot microservices or proper microservice development, so I'm taking a few liberties here just for our simplicity's sake. The configuration would apply if you want to set up multiple MySQL databases. You could, nothing stopping you. But for simplicity here, we're just going to be using one MySQL database. And then also, again, for simplicity, all the code examples I'm putting into a single GitHub repository. We will use a multi-module Maven build, and I will be giving you access to all that source code so you can fully see all these examples. And again, this is for simplicity. In a real microservices environment, we would be, of course, using independent source code repositories. So just a heads up, I'm just making I'm like coloring outside the lines of commonly accepted things for microservices just for pragmatic sake. So to take a look at our actual Kubernetes configuration, so we will be using a gateway. That gateway will expose the different services. So the beer service, order service, inventory service. We will also be setting up the inventory failover. Again, we will be using Kubernetes for service discovery. We do need to have our services, so we will be using MySQL, ActiveMQ for JMS. Those will be all exposed. And we will be deploying this entire thing under Kubernetes. Coming up in the course, in additional lessons, of course, we will be detailing each step here to take these into a Kubernetes environment. Okay, for this course, we are going to be working with the code in the code base here on GitHub. You can see the URL at the top of the screen. That is Spring Framework Guru /KBE-SB for Spring Boot Microservices. So this is the repository that we will be working with in this course. We're not going to be getting into a lot of details here, but I do want to point this out. You can see if things are kind of like ready-made. This is like a ready-made project that we're going to be working with. Again, the focus of the course is on deploying to Kubernetes, so we're not going to spend a lot of time on it. But I do want to orient you to the code base itself. So this is the GitHub repository. I'll be putting a link to this in the course resources as well. And let me toggle over to IntelliJ now, and we'll do a quick code review of what's going on here. Okay, I'm over in IntelliJ here. What we have is a multi-module Maven project. You can see here I've got a number of properties set up for the project. I'm not going to go through this, but we are setting up using MapStruct, Project Logback, as well as the Fabricate plugin for Docker to actually produce the Docker images. We have two things set up. One module is the KBE Brewery Gateway. I found that between the stuff bringing in for the Spring Boot microservices and the Spring Cloud components, I ran into some dependencies issues, so I separated those out. So the gateway, the Spring Boot Gateway project is here. So this sets up all the stuff that we need for the gateway module, and this is going to be building into its own Docker image. And then we have our Spring Boot microservices. We are dealing with 4 of them to be precise. So we have the beer service, the inventory failover service, the inventory service, and then the brewery order service. So these are 4 different Spring Boot microservices. And again, using the Fabricate Maven plugin, we are able to build all these into independent Docker images. We can see here the 4 Spring Boot microservices do have a common Maven POM. So if you're not very familiar with Maven, just to recap, so I have a parent level POM. This defines 2 modules. So we have the Brewery Gateway, SB Services. The SB Services, again, that is its own module. And in that module, we can see that we have the 4 Spring Boot microservices defined. So if we were doing this as a real microservices project in an industry, all these would be in separate GitHub repositories. So the gateway and all the 4 Spring Boot microservices should have their own repository. But for the purpose of this course, it's much more convenient to bring everything together and configure Apache Maven to build everything for us. Now, the one thing that I do want to point out, I have this K8 temp. That is going to be deleted eventually. That is my working directory for deploying to Kubernetes. And then finally, we do have Docker Compose. And this sets up everything that we need to bring up the entire system: MySQL, Elasticsearch, Kibana, Filebeat, JMS, and then the 4 services plus the gateway service. And I'll be demonstrating this in a separate video. Here, I just wanted to orient you to the actual code base. I'm not going to be going through all the Spring Boot microservices themselves. There's quite a bit of code there. Again, this is copied over from my Spring Boot Microservices course, where I take everything step by step, but get some pretty interesting examples as to how those work. And we're going to be focusing on deploying with it. And you can see here in the compose file, we are setting up a number of environment variables to get everything up and running. And I'm going to be detailing this in an upcoming lesson. Okay, up on the screen, I have the Docker Compose file for all of our services. So what we are going to be doing in this course is I'm going to show you how to run this in Docker Compose, even though we're not focusing on Docker Compose for the course. Here, we have a ready-made Docker Compose file that's going to bring everything up that we need for an environment. And as we work through the course, we are going to basically migrate from this Docker Compose. This Docker Compose file has everything that we need as far as like environment parameters and ports and all that jazz. That gives us what we need to set up Kubernetes. So in this video, I'm going to demonstrate running it so you can see the runtime environment. And again, Docker Compose is one type of container management. Kubernetes, obviously, another type of container management. And here we will migrate over. So we'll bring everything up so that you can see it running. And then we'll be shutting it down, the Docker Compose version. And then we have a number of lessons where we will be bringing up each of these components. So let's take a closer look at this Docker Compose file. And I'm not going to get too far down the rabbit hole with Docker Compose, but you can see on line 3, we are defining our MySQL image. So this is what we are using to back the persistence for our Spring Boot microservices. I'm using MySQL 5.7. There's some security changes in 8 that require a little bit additional configuration that I didn't want to get into. This sets it up very simply. That MySQL image allows us to set 2 environment parameters. One is to set the root password, and I'm being very creative in my password there, calling it DB password. And all of our Spring Boot microservices are going to use the same MySQL database. This is being done just for pragmatic reasons. If we were rolling these out into productions, obviously we want to have independent databases, but for pragmatic purposes, we're just going to be using a single database. Now, the next 3 components, Elasticsearch, Kibana, and Filebeat, these are for consolidated logging. We will be taking a look at that. That is going to be the last section of the course as far as setting up the consolidated logging. But you can see here, we've got the definitions. We have to open up some ports. The Filebeat configuration for Kubernetes is going to be quite different from this. So I'm not going to get too far down the rabbit hole as how we set up Filebeat at this point in time. But basically what Filebeat does is it looks at the container logging. So we log out to the console. We have our Spring Boot services set up to do JSON logging. Then Filebeat ships that off to Elasticsearch, and Kibana is the tool that we use to query and view the log traffic. So let me scroll up a little bit here. Now, JMS, we'll have a service called JMS. That's our JMS broker. Needs to expose 2 ports, 8161 and 61616. This image does have a default username and password. The services are already configured to use that, so we don't have to worry about setting anything up for that. And this is providing our message broker. And then on line 34, you can see I'm defining inventory service. And this is coming from the image Spring Framework Guru / KBE brewery inventory service. So this is our one of the core services of the Spring Boot services. This is going to be exposing port 8082. That's where we'll be listening. And then you can see I've got about 5 different environment parameters. So these are overriding what's in the properties file. So remember, in a Spring Boot context, if you set a environment property, that is going to override any properties that are being set in the jar. So in this case, specifically the Spring data source URL, I'm setting that to MySQL. So Docker Compose, like Kubernetes, will take the service name, map that to the IP, so we can use that as a host name. So we are using a host name of MySQL and the URL, and that's how we will locate and talk to the database, as well as setting the user a name to root and DB password for the password. Also, on line 45 there, you can see that we are setting up the Artemis host to JMS. So again, we have the JMS service called literally JMS that will resolve to the IP address that is being configured within the Docker Compose context. We'll have a similar behavior with Kubernetes. And let me scroll up here a little bit to get inventory failover at the top. So this is our failover service. This is probably the simplest one. We're just simply exposing port 8083. We don't need to tell Docker Compose nor Kubernetes about the failover logic. That is application-specific logic, but we do need to tell them how to run the service. And so we have a pretty simple implementation there. Line 54 is our beer service. And again, you can see in this case, I'm setting up 6 environment parameters, giving it the name of the inventory service. So you can see on line 68, I am using inventory service. And again, the host name inventory jazz service has to match the service name. And that's how we are doing service discovery, through looking up of the host name, allowing Kubernetes, or in this case, Docker Compose, to manage that. And let me scroll up to order service. Very similar to beer service, but in this case, we have an environment property to set to beer service to tell the order service where the beer service is. And then the 5 other environment properties are the same. And then finally, we can see that we have the gateway. That is the gateway, Spring Cloud Gateway, that fronts all the microservices. And in this case, I am exposing the ports for each individual service. The way I've set this up is that we can talk to the services directly or go through the gateway. So I didn't have to do that. This is just how I chose to do it, and it gives us some flexibility. So I'm going to toggle over to the command line now, and we'll take a look at running these. Okay, so I am in the root of the project. If I do an ls there, you can see that I'm in the root of the project directory, and you can see that I have the compose local YAML. Now to run that, what we want to do is Docker compose -f for file, and just doing compose and hitting the tab key for the autocomplete there. This will tell Docker Compose to run that file. In this case, we want to say up, and then we will pass a -d to that to run in detached mode, or the background. So let's go ahead and start that. See that we are creating a network for our Docker Compose network for the KBE SB microservices. And you can see each one of these services are starting up for us. And some take a little bit longer than the others, but it's going to take a moment for everything to start up. I'm going to pause the video while everything initializes, and then we'll come back. Okay, we can see everything has initialized. If I do a clear, and now we can do Docker PS, we can see that all the services are up and running. And again, this is in a Docker Compose context, so everything has been brought up in individual containers. Now what I can do is I can come over here to Postman. And in this case, the gateway is exposed on port 9090. And I can come in and make a query of that. And you can see that I'm getting beer information back. So this is going through Spring Cloud Gateway. If I want to go directly to the beer service itself, I can go to port 8080 and query that. And this is going directly to the beer service. So this is making a query from that service directly to that, whereas 9090 is going to be going through Spring Cloud Gateway. Go like that. And that is going through the gateway. Now, one other thing that we want to take a look at is that we do have consolidated logging. I'm going to come over to Chrome. And here, this is Kibana. I know I'm going to have to refresh this. And what I need to do is go ahead and load up some data. So I'm going to say discover. We need to create an index pattern. And I'm going to do Filebeat star. And this is telling Kibana basically how to index the data. We want a time field, and creatively our logging is going to at timestamp. So we'll go ahead and create that index pattern. That sets that up. And now if I come back over here to discover, it takes us a second, but we'll be able to see this is actually data coming back from the various services. So we do have a number of properties being logged, and you can see we get quite a bit of rich information here from these. And I'm not going to go too far down this, but effectively what's happening is we have the 3 microservices running in independent containers. Filebeat is monitoring each container, the console logs, and shipping those off to the Elastic database. And then we are seeing the data here. So again, we are going to be going through setting up the services first, then the Spring Boot Mircoservices, the gateway, and then in the last section of the course, we'll take a closer look at setting up consolidated logging. I'm going to jump back over to IntelliJ. And again, just to recap what we are going to be doing going forward in the course. Initially, we are just going to be setting up MySQL. We are not going to worry about Elasticsearch, Kibana, or Filebeat until the last section of the course. We do need MySQL, JMS, inventory service, inventory failover, beer service, order service, and the gateway. And we will be setting these all up as deployments and services within Kubernetes. And coming up in the course, we will go through each one of these. We will set up the deployment and services as well as the environment properties that are required for each one. Okay, the last thing that we want to do in this video is to go ahead and shut down the Docker instance. So let me come back over to the command line. You can see that we still have our Docker services running. And to shut everything down using Docker Compose, we can do Docker Compose -f and give it the compose file. And we just simply issue the command down. And that will shut down all the services that we brought up with that Docker Compose file. So if you're following along at home, brought everything up. So Docker Compose file name down will shut everything down. And coming up in the videos, we will start tackling bringing everything up in Kubernetes. Okay, in this section of the course, we are going to look at the basically backend services that we need to support the Spring Boot microservices, specifically MySQL and JMS. Typically, each microservice should have its own database. Here, we are only going to be deploying one database, and some organizations don't even like to use Kubernetes for the database. So, arguable, I'll give you that. But for a pragmatic approach in the course, we're going to be standing up MySQL in a container. Granted, we'll lose data. That's another thing that we can tackle in a different course. But just from a pragmatic example, I want to be talking to a MySQL database. We don't really need 3 databases. That really just add a layer of complexity. So from a pragmatic standpoint, I'm only going to use one MySQL database in a container. I'm more focused on getting Spring Boot to talk to said database and showing you how to set that up with environment parameters. We'll be looking at that down the road. The objective of this section of the course is to get MySQL and JMS running in Kubernetes. Okay, the first service that we need to worry about is MySQL. So you can see up here on the screen, I've got the Docker Compose file for that. And we can see on line 3, that's where the service is defined. It's coming from the image MySQL with the tag of 5.7. And then we are setting up 2 environment properties. So we need to replicate this in a Kubernetes context. So what I'm going to do is come over to the command line, and we are going to issue the command kube control, create deployment. We're going to call this MySQL as the service name. And we'll say image. Again, we're going to be doing the image of 5.7, MySQL 5.7. We want to say dry run. And this is just going to tell it to dry run it, not actually create it. And we want the output to be YAML. So -O for output, YAML. And then we are going to pipe it to a file. So this, if you're on Windows, I don't know if this will work for you. It's been quite rusty with the Windows command line. but in any bash environment or Unix type environment should be just fine. And we are going to say MySQL. I'm going to say MySQL deployment. I'm going to use the shorthand of YAML. So this will create the file for us. You can see there's the file. And what we need to do is we need to edit that. I'm going to toggle over to IntelliJ to do the editing there. I could use VI, but for editing YAML, IntelliJ is a little bit nicer for that. So if I come in here, if we take a look at the scripts, there's the MySQL deployment. You can see that it is highlighted in red. I will be adding that to the GitHub repository for your reference. So we're going to see me create all these in this. And here is the file, the specification that was created for the deployment in a Kubernetes context. Yeah, you can see under spec containers, image, 5.7 resources. Now what I want to do is say env for environment. And this is going to take a map of properties of name value pairs. So we want to say name value. I'm coming up with the ever so creative DB password. Then also we need to initialize the database. So we'll say name. And it's just going to be beer service. And all the microservices are configured to use the same database. We could create multiple schemas if we wanted to, but again, just for pragmatic sake, we're not overcomplicating things here. So we can see MySQL root password, MySQL database is being set in the environment properties. And if we come back over here to the compose file, you can see we have a slightly different syntax, but MySQL root password is equivalent to this, and then this MySQL database, that is the equivalent to that there. So let's come back over to the command line now, and we'll apply that. So we can say apply -f, and we can see the MySQL deployment, and that is created. Clear the screen here. And then we want to create a service for this as well to expose the database as a service. Create service. We're going to give it a cluster IP, so this is going to be exposed. It's going to be for MySQL. And we want to say TCP, so we're going to expose a port. And this is the default port. This is where the communications to the MySQL database is going to occur over this port. We'll say drive run. -o equals YAML. And here we are going to pipe it to another file, and we will say MySQL YML, like so. I got a mistake here. You can see that I mistyped here, so it should be equal client. Try that, and that applied, and now we can do an ls. And we can see I've got two YAML files here. Some people prefer to put everything into a single YAML file, so you can do a 3- separator between chunks of YAML to combine them into one. For the purposes of this course, I'm going to do separate files just for, I think it's going to be a little bit easier for people working through the course. And I'm going to follow the convention of service-deployment, service-service. So now we need to go ahead and apply the service. And we can see cube control apply -f service. That is created, and we can see. And now doing a cube control get all, we can see that I have Kubernetes is running, and we can see that the MySQL service is up and running. And then we can see, let's see here. Oh, I'm sorry, the pod. Here's the pod. That is the deployment, and here's the service. So we are up and running properly. So everything looks good here. And I'm going to clear that. And in the next video, we will tackle taking care of the JMS service. Okay, in this video, we're going to go ahead and create the JMS service. So in the Docker Compose file, you can see that I've got the definition up there. You can see that we're pulling from the image v Romero. ActiveMQ Artemis, and then we are exposing 2 different ports. That's for the JMS communication. So we don't have to worry about any environment property. So we're good to go there. This is going to be fairly simple. So let's toggle over to the command line and create this. So here, first we want to create the deployment file. Create deployment, and we are going to call the service JMS. And this is going to be from the image equals B Romero ActiveMQ Artemis try-run equals client -O for YAML output, like so. And we say cube CTO apply -F. So that creates the deployment, the actual pod that is being created. That's going to be the container. And then we can also do clear the screen, get towards the top again. Cube control, create service this time. This is going to be exposed outside the cluster, so we'll give it cluster IP, JMS. And now let's expose the ports. We want 8161. And then also we need to do 61616. Again, that's going to be dry run, output of YAML. Got a typo there. TCP equals apply -F, JMS service this time. And this is going out creating service. I clear all this. And getting all, we can see that we now have a JMS pod, a MySQL pod. We have the 2 services that we've created, JMS and MySQL. So this is exactly what we want to see here. And if I do clear, if I do a Docker PS, we can see that we have 2 containers running in a Docker context on our local host. So let's toggle over to IntelliJ real quick and we'll review what we created. So the first thing that we created was this JMS deployment. We used the kube control command. We haven't had to touch anything in this file, so this was created through kube control. We didn't have to override anything, so no edits were made to this file from that command. And then also we created the same with the service. You can see that we did use the TCP parameter twice, and that was created those 2 port mappings for us, so exactly what we want here as far as exposing the ports. Okay, now with our infrastructure services in place, we can start focusing on the Spring Boot Microservices. We actually have 4 different services. We frequently say 3 because one of them is a failover service, and a fairly light service. And then also we have a gateway service. So technically, I guess you could say there's actually 5 services that come into play. But in this video, the 3 core services that need to be talking to MySQL and JMS, we're going to be looking at those, setting up the environment properties, how we do service location with Kubernetes in a Kubernetes context. Very similar to Docker Compose. I think you'll be pleased to see how everything comes together. But what we want to be doing is we want to create the deployments and the service specs for each one of these services. We will need to edit the YAML for the environment-specific properties that we need to set, and I'm going to go through each one of those services and show you exactly how to do that. Then we will set up Readiness and Liveness probes as well on the services, so we are proper citizens in a Kubernetes context. And then with Spring Boot 2.3 or higher, we can do a graceful shutdown to allow the JVM to stop anything that's in flight as far as processing and shut down gracefully. So we'll configure Kubernetes and Spring Boot to allow for that. And then finally, we'll be setting up the Spring Cloud Gateway to allow us to access those. So we're going to cover a lot of content in this section, a lot of really cool stuff as far as Spring Boot running on Kubernetes. So we'll have by the end of this section, we'll have a very realistic set of microservices communicating, and we'll be able to go in and access those services. So I think you'll get a lot out of this course, and you'll see a lot of how we can configure Kubernetes to support our Spring Boot microservices. Okay, in this video, what we want to do is set up the inventory service for Kubernetes. So we want to create the deployment as well as the service descriptor. And here on the screen, I've got the Docker Compose for that. You can see that we're going to be exposing port 8082. And then we've got the 5 environment variables that we need to set. And let's go ahead and start doing that right now. I'm going to toggle over to the command line and create that file using kube control. Okay, we want to go ahead and create the deployment definition first. So we're going to do kube control, create deployment. That is going to be inventory-service. It's going to be from the image. That'll be KBE, KBE Brewery Inventory Service. And this is going to be a drive run from the client. We want it to be formatted to YAML. And we are going to redirect that to inventory deployment. And I got a typo there, not dry client, it's dry run. And that creates the file. And I'm going to toggle over to IntelliJ and we'll go ahead and edit that file. And we are working under scripts, so you can see that's a new file that's been added. And what I need to do is I need to add in environment properties. And this is going to take in a list of values. It's going to have a name and then also a value. And I'm going to pause the video and fill these in. I don't think you want to see me type in 6 different values here. So I'm going to pause the video and then we'll do a quick code review of that. So just coming over to the Docker Compose file, you can see for the inventory service, I've got 5 properties, data source, user, password, the Hibernate DDL, data source URL, and host. So these values need to be defined. And to do that, we're setting up name value pairs. So there's the name of the property as well as the value. And we've got the 5 different properties defined. So that completes setting up the inventory deployment. This is how the inventory service will be deployed. And let's come back over to the command line and we can say kubectl apply -f inventory deployment, like so. And that is going to create the deployment or the pod. Now we need to create the service. So that'll be kubectl create service. And we want cluster IP. And this is going to be inventory service. And this is going to expose port 8082. And again, we want dry run. And we want to output as YAML. Like so. And then we can also apply that. That creates that. Now if I do a kubectl get all, you can see now we have the inventory running in a pod. That is our deployment. And then we also have a inventory service up and running, and we can see that the port 8082 has been exposed for our use. So let's toggle back over to IntelliJ. We created inventory deployment and inventory service. So the deployment, you can see here on the screen, we created that using the kube control command, and then we had to come in and edit to add in these environment properties. Inventory service itself, that was just created with the command kube control, and this is the direct output of it. There was no modifications made to that file. In this video, we're going to go ahead and configure the inventory failover service. Again, this is going to be a service that's just going to be responding back with a positive response for the inventory service. And that's if the inventory service is not available. There's really no Kubernetes configuration to do for this. It's more application logic to utilize one service over another if the preferred service is not available. That's all application logic. But for our deployment to Kubernetes, we do need to define that service. So let's toggle over to the command line and do that right now. That's going to be kube control. And in this case, we are going to be able to do everything right from the command line. So create deployment. And in this case, it's going to be inventory failover. Spring Framework Guru, and this is going to be KBE, and failover this time. I'm not specifying a tag. Try-run equals client -o equals YAML, and we'll call it inventory failover. YML, that creates the failover, and we do cube control and apply that. Inventory failover deployment.yaml. That creates the pod for us. Clear. And now let's go ahead and create the service. Create service. Cluster IP. Inventory-failover. And this is going to be running on 8083. Try run client. -o for YAML output. And in this case, we want to say service. And that creates a service. And in this case, we can say inventory service, cube control, apply inventory failover service, like so. And that creates that. Clear the screen, and let's go ahead and take a look at what's running now. And now we can see that we have, getting a little big for the font here, but we have the pod inventory, failover, the services of inventory failover, JMS, Kubernetes, MySQL. So all that is looking good for us. Okay, in this video, we want to go ahead and set up the beer service in Kubernetes. And you can see up on the screen, I do have the beer service on the Docker Compose. And in this case, you can see that our setup is very similar to inventory, except we have one additional property we need to set, and that is for the inventory service host there on line 68. So let's go ahead and start creating that. I'm going to toggle over to the command line to use kube control to create the initial YAML file. So first thing we want to do is issue the command kube control, create deployment, and we'll call it beer service. That's going to be the name of the service. It's going to come from the image. Again, this is going to be pulling from Docker Hub, so I have these images up in Docker Hub for your use. And this is going to be a dry run equals client. We want the YAML output. I'm going to redirect the output to the file beer service deployment YAML. And let's come back over to IntelliJ and we'll go ahead and edit that file. And in this file, we want to set up the environment properties. And I'm going to pause the video and set those up and we'll do a code review. So I've resumed the video, and you can see up on the screen starting at line 25, this is where I'm defining the environment parameters and name value pairs. And everything looks pretty much the same. So you look at the Docker Compose, so we have the property name and the value, and we have 6 of them, and you can see here that we have 6 of them. And again, here we are setting up the inventory service. So remember, the inventory service, that is going to match the service name, and then that becomes effectively the host, and the IP is resolved within a Kubernetes context. So that is exactly what we want for this deployment. I'm going to come back over to the command line and we'll go ahead and apply that. Beer service deployment. See, that went ahead and was created. Now let's go ahead and create the service component for that. So create service cluster IP. It's going to be beer service, and this service is going to be exposing port 8080. And also we need the dry run flag. Tell it to output YAML. And we'll redirect that to beer service YAML. Technically, I guess, following the naming convention, we should do beer service, but I think beer service YAML is perfectly fine for our purposes. And we'll go ahead and apply that, -f. And that's beer service YAML. And let's see here, I made a mistake calling that beer service YAML rather than YML just for consistency. I'm going to do beer service YAML. So that looks a little bit better. And then let's go ahead and do kube control, get all. And now we can see that we have the beer service pod running. Actually, you can't quite see that. Scroll up a little bit so we can see that's the top pod running. Then we also have the service running, and we can see the various deployments. So everything is up, and it appears to be working properly. So let's go ahead and clear that. I'm going to toggle back over to IntelliJ. Again, what we did in this video is we created two files, beer service deployment and beer service YAML. The beer service deployment is mimicking what we'd set up for the Docker Compose as far as setting up the necessary environment properties to override and set things up for the Spring Boot context. And then the beer service.yaml exposes that service as a service within Kubernetes context. Okay, in this video, we are going to go ahead and set up the order service. So you can see on the screen here on line 72, I have the order service definition from the Docker Compose file. And the key takeaway here is that we want to be exposing port 8081, and we have 6 environment properties set up. Very similar to the other 2 services, except on line 86, we are setting the beer service host. So just a slight divergence there. And again, the beer service, we are setting the host name equal to service names, and that is how we will resolve that service. So let's go ahead. I'm going to come over to the command line and start setting this up. So we use kube control to go ahead and create the initial YAML file. So we're going to go ahead and create a deployment, and this is going to be for order service. And this is going to come from the image Spring Framework Guru / KBE brewery order service. We're going to do dry run client, use YAML output, and we'll direct that to order service deployment. And I got a mistake there. Oh. Need double dashes there. That should do it. Okay. Now let's come back over to IntelliJ, and we'll go ahead and edit that. See, this is a file that we created through kube control, and what we need to do is set up these environment properties here, these 6 properties. I'm going to pause the video while I do that, and then we'll come back and do a code review. Okay, I've resumed the recording, and you can see on line 24 I added in the clause for the environment. So we have the environment and then 6 name value pairs, setting up the environment properties to configure the Spring Boot microservice. Key points being that we are setting up the host to MySQL for the MySQL database, JMS for the JMS broker, and then also the beer service host is running on port 8080 at the host of beer-service in a Kubernetes context. So let's toggle back over to the command line now. And what we want to do is apply that file, order service deployment. That is going to create the pod in the background for us. And now we want to actually create the service definition. Cluster IP is going to be order service. And in this case, we're going to do 8081. Dry run equals client minus O equals YAML for YAML output. So I'm going to redirect that output to a file called order service. And then we can do kube control apply minus F order service YAML. See how it is created. And if I do a Docker PS, we can see the various containers running in a Docker context on the host. And then if we can do get all to see the environment being set up here. So I've got to scroll a little bit now. You can see that we have beer service, failover service, inventory service, JMS, MySQL, and then finally order service. And then those are the pods running. Those are the Docker containers. And then also we have the services running. And we can see we got about 6, 7 of them now. So right now we have our core services, so the JMS and MySQL running, as well as the 4 Spring Boot microservices are up in our environment. And Kubernetes is running all these applications for us. So let's toggle over to IntelliJ and just do a quick review of what we did. So I added the file, I created the order service deployment using the command line, kube control from the command line, and then we had to edit the file to add in the 6 environment properties. And then the order service, we did not have to edit this file. We did create that purely from the command line, and then we did the apply command to apply that to our Kubernetes environment. Okay, in this video, we are going to set up Readiness and Liveness probes for Kubernetes. So basically, when a pod is up, Kubernetes has the ability to be configured to see if the service is ready. So there's a certain amount of time that you need for startup to initialize the service. Arguably, Java can be a little bit longer in some cases. Also, we have liveness to make sure that the service has not hung up. And in Spring Boot 2.3, they added endpoints to Spring Boot Actuator to support this. So to enable it, first off, you need to be on Spring Boot 2.3 or higher. In the services that we're using right now, they are on Spring 2.4, if I remember correctly. So we are definitely ahead of 2.3. That's been out for over a year at this point. Here, we just need to enable it. So you can see on line 35, I'm setting a system property, management endpoint health probes enabled. So this is setting those up to be enabled. And then specifically, we are doing the readiness state enabled and the liveness state enabled. So this takes care of the Spring Boot configuration. Now what we need to do is actually set up Kubernetes to actually look at those. So to do that, what we want to do is I'm going to come in here, and this is in the container definition. So make sure that we are, YAML can be a little tricky, so that's why I like using IntelliJ here. I can see exactly where I'm at. So I'm still in the image definition. And here what I can do is define the readiness probe. And that's kind of a weird looking word to me. So we do readiness probe. And here we are going to do HTTP get : and this is going to be running, this is the inventory service, so this is going to be on port. I double check this. 8082. And we want to say path. It's going to be actuator. So it's be actuator health readiness. So that takes care of the readiness probe. So just to reiterate, there's 2 components to this. So one is the readiness state enabled. That sets up Spring Boot to be enabled. And then this clause here in the YAML, readiness probe, HTTP get, that is telling Kubernetes to do an HTTP get to port 8082 to the path of actuator health readiness. So, and then we also need to set up the liveness. So liveness. And again, that's going to be an HTTP get. And as you can guess, this is probably going to go actuator health, and that's going to be liveness. And again, that's going to be port 8082. So that configures that piece there. And what we want to do is we want to apply these to all the services. To save you from watching me do a bunch of typing, I'm going to pause and I'm going to edit the other files and then come back and do a code review. So what I've done is I've gone in and modified the other deployments, both for the inventory service and the order service to enable those. We could optionally do failover. I'm not going to bother setting up failover. It's pretty simplistic. If you want to, you can go ahead and do that, but more interested in having these run properly. The 3 core microservices, the failover service is like a really simple Spring Boot microservice. So now the last thing that we need to do is actually reapply these. So what we can do is come back over to the command line. Let's do clear. Inventory deployment. beer service deployment. And then we also need to do the order service deployment. And here, you can see here, if we keep refreshing this, we can see here we have an order service creating. So because I did the apply action, what's happening is that Kubernetes is shutting down the old pod, the old container, and bringing up a new one with a new configuration. And if I come in and do a get all again, we can see that now we are running. Actually, we're still going through reinitializing them. So that's going to take a couple seconds to settle down. But once the services do reinitialize and start back up, Kubernetes will be happy and everything will be working again. So let's come back over to IntelliJ just as a quick recap of what we changed. Let's do the inventory. So we added in 3 new environment properties to enable the readiness and liveness endpoints in a Spring Boot actuator context. And then also we set up the readiness and liveliness probes to go ahead and do those. And I just realized I made one mistake here. So beer service, that is on 8080, the beer service deployment. That should be 8080. And that could be why that was restarting as well. And order service is running on 8081. We want that running on 8081. Like so. And let's come back over to the command line. And we want to do the order as well. Remember, whenever we make a change to the deployment, we do need to reapply that, and that will tell Kubernetes go ahead and redeploy that. So again, that take a minute for that to come up, but that is how we set up the readiness and liveliness probes inside of Kubernetes using Spring Boot actuator. Okay, one other feature that was added to Spring Boot 2.3 is the ability to specify a graceful shutdown. So the way containers shut down, that can be quite abrupt, and you can have like half-baked transactions, so to speak. Things might not be finished processing. Having a graceful shutdown gives the application the capability to get to a graceful state for having everything done, so to speak. So you want to give it a couple seconds to get anything that's in flight completed rather than just terminating it abruptly. So I'm going to show you in this video how to set that up. Again, it's 2 things that we need to do. One is to set up Spring Boot. We need to configure Spring Boot to enable this capability, and then we need to make Kubernetes aware of this capability. So the first thing we want to do is come in, and I'm going to look at the inventory deployment file. We would need to add in another environment property, and this time it's going to be name. And creatively enough, this is called server shutdown. And the value we want to set is going to be graceful. So again, if there's some type of in-flight database transaction, or if we're reading from a queue, we'll get that work done before we terminate the JVM. So this sets up the Spring Boot configuration. And then for Kubernetes itself, we want to go in and add in lifecycle, and we'll call this pre-stop. And we're going to execute a command. And basically, we're going to tell it to sleep for 10 seconds. So we're going to execute a shell command. And the syntax for that is going to be sh for shell. It's a little weird how you have to escape every string into a common set of strings. Then comma C. And then sleep 10. So we have a comma list of strings here. That's a shell command, minus C for a parameter, and then sleep 10. So this is going to tell Kubernetes to sleep for 10 seconds as it's shutting it down, and that will allow Spring to go ahead and shut things down properly. I'm going to pause the video and apply this to the other two deployments real quick. So let me pause it. I'll be right back. So for order service and the beer service, I've also applied the same values. You can see now we have the environment property, server shutdown, Graceful, and the stanza and the container image, lifecycle pre-stop, exec command sleep 10. And the last step we want to do is we're going to come over to the command line. And what we want to do is say cube, apply -f, inventory deployment, and we ran into an error. So let's take a closer look at that. Oh, I see what I made, per stop. So this should be pre, and I'm pretty sure I copied that. Very simple mistake there. I mistyped the pre-stop, not per stop. So let's come back over to the command line. And say the same. And I'm just going to make sure that's saved. Let me pause this and take a closer look. And when I returned, I saw that I did in fact miss the per stop in inventory, so I'll double check. Order is correct, and inventory, beer, so they're all correct. So that's working better. And we want the order deployment as well. So that, by doing a apply -f, the deployment, again, that's going to tell Kubernetes go ahead and reapply those, and it will recreate those. And we can see here like the inventory service that is terminating. We also have a beer service terminating, and we can see that a new one is starting up. So by doing that apply, shuts down the old one, brings up a new one, and gets that ready for us. So those values have now been set, and our Spring Boot applications will shut down gracefully. Let me toggle back over to IntelliJ just to recap. Again, the two things that we need to apply first is an environment property called server shutdown Graceful that enables Spring Boot for that. And then for Kubernetes to be sensitive to that, we are telling Kubernetes to, before stopping it, give it 10 seconds to allow it to finish processing. In this video, we're going to talk a little bit about Kubernetes Ingress. So Ingress is how we get in and out of the cluster as far as in a networking perspective. So if we want to make a request that is going to be handled by a Kubernetes cluster, we will be going through some type of ingress into the cluster. So you can see here we've got some important terminology. We have node, it's a worker machine and part of the Kubernetes cluster. And one of the things that we're against is in our demo right here is that we are running on our local machine. So we are a single node, air quotes, cluster. So Kubernetes, when it's deployed, it can be clearly on multiple machines, might even be in multiple data centers. So there's literally thousands, if not more, ways to deploy Kubernetes. So a cluster is going to be a set of nodes. And again, for our purposes, we only have one node in our cluster because we are running on our local machine. If we were running on AWS, we might have a set of servers that we've provisioned for Kubernetes. So there's just a lot of different things that we can do as far as how things are going to be deployed. The edge router, again, that's going to be some type of device that could be routing traffic into your Kubernetes cluster. So let's come up here and talk about this. What is Ingress? So the client is going to make a HTTP or HTTPS request to a host name, some type of host name and path. And that path is going to be serviced by something. Now, some type of endpoint, that Ingress endpoint, that is going to be coming into the cluster. Now, your service and pods, that is all handled by Kubernetes networking layer. So this is kind of like a virtual networking layer that typically we are not going to be interacting with at all. Kubernetes has tools to manage that. And what I want to stress in this video is that there's a lot of different ways that we can skin this as far as how we get into this. And let me come up here to Ingress controllers. And here we can see some popular Ingress controllers for Kubernetes itself. Let's see here. You can see here, Kubernetes itself, there are controllers specifically for AWS, Amazon, Google Cloud, and then Nginx. These are all very popular Ingress controllers. Again, it's highly dependent on what your environment is. So if you're using AWS, obviously you might want to be using AWS load balancers. Likewise for Google Cloud Foundry, might want to do that. Nginx, that could be some type of custom cloud environment. If you are running your own data center, here we have F5. I don't know a lot about F5s other than that they are very expensive and they can handle a crazy amount of network traffic. But the key takeaway that I want you to have here is come back here is coming into this Ingress controller here, there's going to be a component that is going to be routing traffic into that. And we are somewhat limited because we have a single node. To emulate that, the simplest thing for me to do, showing you that what we are going to be doing is taking Spring Cloud Gateway and setting that up as our air quotes Ingress controller. So I'm going to be setting that up. We will be exposing it on a port on our node port. So we'll get a random port assigned by Kubernetes that we will be able to go through the Spring Cloud Gateway into our microservices. And I decided to record this as a specific video to allow us to think about the deployment and understand the limitations of running on a single machine and also all the deployment options. A lot of times you will be standing up services and pods behind all this, and the actual ingress is going to be handled by a DevOps team. And you as a developer is really not going to have a lot of control over that. But you need to be aware of that and that they will be routing traffic to that. And you might have, so using our example, your beer service could be running in a cluster of machines on one Kubernetes cluster. Your inventory might be on a completely different Kubernetes cluster, and there might be some type of ingress controller in front of that managing all that. So there's a lot, I cannot stress this enough, there's a lot of different ways that we can control that. Here, the takeaway I want you to have is understanding that there's a lot of diversity, and really there's no right answer. There's just a lot of people have opinions. A lot of people have dependencies on the deployment environment that they're in, personal preferences. Here we are going to be mimicking this piece using Spring Cloud Gateway and a service type of a node port. And we'll be looking at that in the next video as we set things up using Spring Cloud Gateway as our, I'm saying this in air quotes, a ingress controller for Kubernetes. And again, there's a lot of different ways that we could do this. For the purposes of this class, I felt that Spring Cloud Gateway was probably the simplest approach because it allows us to see a couple things as far as service discovery and whatnot, and routing to our services within the Kubernetes cluster, understanding that the Kubernetes cluster is going to be handling all the networking between Spring Cloud Gateway and the actual services and the pods that it's deployed on. In this video, we are going to be looking at setting up the gateway. This is a Spring Cloud Gateway instance as a service and deployment inside of Kubernetes. Again, this is going to be mimicking some type of Kubernetes ingress. And we covered that in the previous video about what all that means. But here, we want to go in and configure this. So let's take a quick look at the gateway configuration. I'm doing it through Java. A couple different ways that we can configure Spring Cloud Gateway. Here we can see we have routes, IDs, creatively named beer service, inventory service, and order service. And you can see here this is mapping to an HTTP route. So beer service goes to host beer service 8080. Inventory goes to inventory service 8082. And then finally, order service 8081. So these are things that are being mapped in the gateway controller. And then those host names, those are going to be managed by Kubernetes, enabling our service lookup to find out where those services are through the host name, and then our traffic will be routed there through the Spring Cloud Gateway. So this is configuration. What's important is that Kubernetes is able to resolve beer service, inventory service, and order service. So we've already done that configuration. What we need to do now is go ahead and set this up. You can see here from the Docker compose definition for this, pretty straightforward. All we're doing is exposing port 9090. And other than that, there's nothing for us to be concerned with as far as a deployment under Kubernetes. So I'm going to toggle over to the command line now. And here what we want to do is set up the deployment. Simply going to call it gateway. KBE brewery gateway. We need the dry run. Dry run equals client -o for YAML output. And we will redirect that to gateway deployment.yaml. And we can do kubectl apply -f gateway deployment. And this is going to create the deployment, the pod for the gateway service. And then we also need to do control, create service. And here we're going to say node port. We'll call this a gateway. And again, we want the dry run option. -o for YAML output. And we are going to redirect the output of this command to the file gateway. And of course, we want to apply that. So we're going to say kube control apply gateway service. That sets that up. And here we can see that we are definitely getting a lot more going on in this. So here we can see the pods that have been set up. So we have our beer service gateway, inventory failover, inventory service, JMS, MySQL, and order service. So all this is up and running. Just glancing at everything looks like it's running normally. And we can see gateway. So internal to the cluster, the gateway is running on 9090, but on localhost it's on 30499 or 30499. I am going to just copy that value. And what we can do is we can come over to Postman now and go ahead and paste that in. So we can see localhost 30499. That is the port, the node port that's been exposed by Kubernetes. And that is for the gateway. And we can see that I am now getting the proper response. So you can see I'm getting beers back from the beer service. So what this means is that, just to help you visualize this, so we are going to localhost port 30499. This is going through, toggle back over to the command line. So the gateway service is listening on localhost 30499, and Kubernetes is routing that request to the gateway service. The gateway service is routing the traffic to the beer service. So we are going through the gateway to the beer service that is running on port 8080. And this all abstracted by Spring Cloud Gateway and Kubernetes. Kubernetes is assigning, you can see here, we don't need to know that the beer service is running on this internal IP of 10.101.152.102. Kubernetes is handling all that, and the traffic is going through the local host port 30499. And then Kubernetes is routing that to the gateway service. The gateway service has a reference to the beer service, and the beer service is handled by the Kubernetes networking to get the request to this pod that is running here. So very important to remember that localhost is running on the network of my local host, and this IP technically is unreachable without doing some special commands, but this is effectively unreachable for us from the local host network. We are going into the Kubernetes network, and Kubernetes is managing and routing all that traffic. So things are getting routed in and out of our service, and we can see that it's working properly. Let's toggle back over to Postman. Yeah, we can see that the performance is actually fairly decent. as far as getting that request in and out of the beer service. So I toggle back over to IntelliJ. We used the Kubernetes command line kube control to create 2 files here, and we didn't have to modify them at all, because what we were doing is we're setting up the brewery gateway. We created the deployment. This was generated from the command line. We did not have to modify that at all. And really all we're saying is that we are using this image. The configuration has already been done. That is hard-coded effectively. Not necessarily something that we always want to do. There's a way to do configuration parameters with Spring Cloud Gateway. I'm not going to get into that at this point in time. But that is hard-coded to go to those service names. And then also we set up the service. And the important thing here is that the service has been defined as a type of node port. So node port is going to expose that service on a randomly assigned port by Kubernetes. And when I come back to the command line, when I do kube control get all, when we do kube control get all, if I look at the gateway service, I can see that it is a node port, and the port on the local host has been 30499 has been mapped to the port 9090, which the gateway service is listening to on the Kubernetes internal network. Okay, in this video, we're going to talk about deleting services and deployments. And actually, there's a couple different ways that we can accomplish this. Let's take a look here. I'm just going to do get all. And we can see that we do have a number of services and deployments running. I'm going to scroll up here. So we can see that we got about 6, 7 pods running, and as well as services. And because we've been doing everything with YAML files, what we can do, we can actually go in and tell Kubernetes to delete each one individually, or we can do things like delete service or delete pod, or delete deployment. The other thing we can do is we can come in. So we'll pick on the gateway just for example. So we can do kube control delete -f gateway service, and we can also do gateway deployment. And if we come back here and do get all, we'll see that the gateway components have now been removed. So you can see here, we got quick enough so we can see the gateway pod is terminating. So that takes a few seconds for that to terminate. This allows us to see how we can add or remove services and deployments fairly quickly using the YAML file. So we can do those specifically by name or by the YAML file that we created. And if you have more complex objects, more things in the YAML file, this becomes very convenient to do. So again, I'll just show you that command again. So it's kube control delete -f and then give it the file name. But we do want our gateway there. So let me clear this. Apply -f gateway deployment. And we also want to do the gateway service, and that will restore that. So if you're doing significant changes, or if you just don't want these running, kube control delete -f and file name is a real handy way to remove components from your Kubernetes environment. The last thing I wish to cover in this course is consolidated logging. Now, the problem of running in a distributed environment, we have logs running in these containers all over the place, which, if you're troubleshooting something, that can become very difficult, especially if you're going from multiple services. So what we are going to do is we want to take all that log data, consolidate it, and get it up to Elasticsearch where it can be searched using Kibana. Kibana is a great graphical userface to look at data inside of Elasticsearch, so the two work really well together. We will be using Filebeat, which is a very efficient tool to go and grab the log data to get that in. So a lot of moving parts here, and let me prefix this. There's a lot of different ways to do consolidated logging. The Elasticsearch, Filebeat, and Kibana are very popular. That's why I chose this stack. Again, there's a number of different tools, but this is a very popular stack, and I like Kibana. It works really well as far as a search tool. We will also be utilizing Spring Cloud Sleuth, which will give us a trace ID that if we have a request going across multiple services, Spring Cloud Sleuth enables that. So for a Spring context, allows us to trace hops across multiple services. So pretty cool capabilities that we have here. By the end of this, we will have all our microservices providing log data to Elasticsearch using Filebeat, and we'll be able to go into Kibana and search the log data. Okay, in this video, we're going to talk about logging configuration for consolidated logging. So we have a couple things at play here. And in my course on the Spring Boot Microservices, I do cover this in a lot more detail. The Spring Boot Microservices we're using are already configured to support this. So I'm just going to do a quick code review to show you the key pieces of the puzzle. So one thing here, to get the JSON logging, we have this log stash. By default, Spring Boot uses Logback for logging. So this is a log stash logback encoder. Basically takes the log data and creates JSON output. So that is one piece of the puzzle. Another important piece is Spring Cloud Starter Sleuth. Sleuth is a project that is going to add tracing elements. So you'll get a correlation ID passed through your services. So if service A calls service B, Spring Cloud Sleuth is going to provide data in those logging calls so that we can see a trace ID to help us trace a call through multiple services. And I'm not going to get too far down that rabbit hole. Just wanted to point out these two components. And then finally, the other piece that we need to be looking at is under resources. We have this logback spring.xml. A lot going on in this, but this is going to be setting up our logger. Specifically, we want a console appender, and the encoder, we're going to be using this logging event composite JSON encoder. So this is the primary piece that is going to be taking the log data and making a JSON object out of it. And that is important because we're going to be posting JSON to the console, and then Filebeat is going to be picking up the console logs and shipping those to Elasticsearch. So that's how everything fits together. I'm not going to be able to go through all of what's going on in here, but very important to have this. And then remember, I mentioned the Spring Cloud Sleuth component. That is going to be this piece right here, where we have the trace ID and the span ID and parent span ID. This is all going to be coming from data in the logging, so we'll be able to see those trace and span IDs of requests going across multiple services. So very, very important piece to work with as far as seeing the consolidated logging if we have multiple services involved, specifically what Spring Cloud Sleuth is for us to see. So just to recap, the two things that we need as far as dependencies is the logback encoder to get the JSON output, and then the sleuth component that is going to give us the trace IDs, and then finally having this logback spring.xml on the class path. So this is already built into the Spring Boot microservices and configured, so the services are doing effectively JSON logging. And we can also see here the Spring property context, Spring app name. So each microservice has a unique Spring application name, and that is included in the log as well. Okay, in this video, we are going to start configuring our consolidated logging. So Elasticsearch is the database that is going to be holding our consolidated log data. On line 8, we can see that we have the Docker Compose configuration for Elasticsearch. Pretty straightforward. We have one environment property we need to set. That is discovery type single node. And then we need to expose port 9200. So let's toggle over to the command line, and we will start working on that. So to set this up, I'm going to use kube control. I'm going to create a deployment. Call it Elasticsearch. And that image is going to equal, I'm just going to copy that. That's quite a bit to type out. And here we want to set up the dry run client, and then -O for YAML output. So that creates the YAML file. I'm going to toggle back over to IntelliJ, and we want to set up a property, environment property of discovery type. I'm going to copy that on over, and here under resources, we want to say env. Remember, this is going to be a list. Name, so that discovery type, value, and this, you can see that we have single dash node. So that sets up Elasticsearch. So let's come back to the command line, and we can do Elasticsearch deployment, and that is going to create the Elasticsearch deployment, so a pod and a container will be created for that inside of Dockers. And now what we want to do is go ahead and set up the service for that. So kube control, create service, and this will be a cluster IP, because we don't need access from the outside. Elasticsearch, and TCP, we're going to expose 9200. Dry run equals client. And we'll redirect this to Elasticsearch YAML file. That's created. And then let's go ahead and apply that. And that is created. And coming up, we can see that we have a lot more stuff running. Under our pods, we can see that Elasticsearch is up and running. And we have an Elasticsearch cluster IP. Port 9200 is exposed, so exactly what we want. So let's come back over to IntelliJ. You can see that we added in the Elasticsearch deployment, and we did have to edit this file to add the env property, name, discovery type, value of single node, the Elasticsearch service. This was generated purely from the Kubernetes command line, and there's no editing required to this file. We just do kube control apply to create the service as previously shown in the video. Okay, the next thing that we need to configure is Kibana. And the Kibana configuration is going to be fairly simple. We really don't need to set any environment properties. All we got to do is expose port 5601 and reference this image. So I am actually going to copy this over right now. So I'm copying that to my clipboard, and then I'm going to toggle over to the command line, and we will use kube control to create the necessary deployment and service descriptor. So let's go ahead and create the deployment file with kube control. So create deployment Kibana, image equals, and I'm going to paste that so I get that whole Docker Elastic Kibana and the reference to the proper tag, which is 7.12.1. That's the most current release at the time of recording. Dry run equals client -O, YAML output, and we are going to direct that to file deployment, like so. And there's nothing else for us to configure as far as the deployment. Didn't have any environment properties to set, so we can go ahead and use kube control to deploy that. Apply -F. And we can see that deployment's been accepted, and we are spooling up a container for that in the background right now. And now what we want to do is create the service for it. So let's go ahead and do. And the service this time we want to do node port. So we'll map that node port 5601 to localhost port using Kubernetes node port capability. So we'll say node port. And this will allow us to get to the Kibana console using that port from our browser on our local machine. So let's see your node port, Kibana, TCP equals 5601. Dry run equals client. -O for output to YAML. Kibana service YAML. And then let's just go ahead and apply that. Yeah, let's clear our screen. We're going to go ahead and do get all. And we can see that, let's see here, got the Kibana service node port, and we see that Kubernetes is mapped 5601 to host 30518. So if I went into my browser right now and went to localhost port 30518, I would see the Kibana console, and that Kibana console would be running from this container, the pod Kibana. So that looks like it is up and running properly. So everything appears to be happy with all of our services now. Let me come back over to IntelliJ. And in this, we added in 2 files. Both of them were created from the command line. The first one was Kibana deployment. We used kube control to complete this. We didn't have to do any edits to this file. And then also with the Kibana service, that was also created from the command line. And again, no edits to that file. We've already deployed those to Kubernetes. Okay, in this video, we are going to be setting up Filebeat to run on Kubernetes. So we already had it running in a Docker Compose context, and there's some distinct differences between a Kubernetes environment as well as Docker Compose. For our purposes here, we need to configure it for those subtle differences between the two environments. And I'll be honest, it took me a few hours to get this going right. There's some small nuances there. And here, this is an example that Elasticsearch puts out to show you how to set up Filebeat running in a Kubernetes environment. And what I like about Filebeat, it is pretty efficient as far as shipping the logs over to Elasticsearch. And you can see here they're providing us a script that is going to run in the namespace of kube system. And I'm going to override that. And there's a number of things that we haven't discussed in the course here. I'm going to come over here to, this is a manifest file, so it's saying to download the manifest file, run this, and that is the manifest file here. And a few things that we haven't seen here, this is a configuration map, and what's important about this is telling Filebeat how to configure itself for your environment, and we'll be modifying that, and I'll be showing you that coming up in the video. But here there's a few things that it runs as a daemon set, and effectively what this is doing is setting up some security to allow Filebeat to run on every node of the cluster. So it's very important if you're going across clusters. What Filebeat needs to do is it has to have an instance on every node so it can watch the containers running on that node and pick up their files. So for our purposes, a single node is not very exciting, but very important if you're in a distributed environment with a lot of different nodes. So what I'm going to do is I made a few tweaks to this file. What I'm going to do now is toggle over to IntelliJ and start going through those changes. Okay, so here at the top of the screen, this is the original configuration in Docker Compose. You can see we are going from Filebeat 7.12.1, and here we are setting up the configuration file where the logs are, and this is slightly different than a Kubernetes context, and then some information, so allowing Filebeat to connect to where the logs are and read those logs. So this configuration is for that. And then the other important aspect is we are sharing this configuration file. So we're using a volume share to share that configuration file. This is the original configuration file that's running for Docker and Docker Compose. So this is what we were previously using when we brought it up. Now, when I showed you the GitHub manifest, this Filebeat Kubernetes.yaml, this is a copy of that. And here, I close this search window. Originally, it was running in the namespace of kube control. That is how they originally set it up. I've switched that over to run on default. All of our services are currently running in the default namespace, so very important nuance there. Again, something we haven't talked about in the course, but what we need to do is set up Filebeat to look at all the containers, and specifically containers that we want to be pulling data for. So remember, we're running a number of nodes. So we have JMS, we have Kibana, we have MySQL. We don't want log files from those. We just want our Spring Boot services. So what we I'm done here is under the auto discover, we are saying Filebeat auto discover Kubernetes. This node allows it to go through all the nodes. I'm saying hence enabled true, and actually I don't need this. Just get rid of that on the fly now. And the main thing here is hence default config enabled equals false. So this is saying I'm turning off Filebeat everywhere. So don't look at Filebeat, but I'm going to be turning that on per container. So effectively what we want to do is tell Filebeat to process logs. And when it's processing logs, it's going to be looking on the host system running the node, be looking at var log containers. And if you're running on OS X or Mac OS, it's actually going to be running in a virtual machine on your system. So Docker runs in a virtual machine. I'm trying to remember. I don't remember if it's that way in Windows or not. I want to say Windows is similar, but I could be very wrong on that. I'd have to go to the Docker documentation on that. But here we are setting up how to get to the logs of the individual containers running on that node. And here I'm setting up a processor. So our log message, the log message from our log output is put to a field called message in the log output, and it is a JSON body. So what we're saying here is we want the processor to decode that JSON. So a very important aspect is that it's going to decode that JSON body, and we'll see that come into play inside of Kibana. So this file here sets up Filebeat itself. You'll need to set this up. And the main thing that I changed was the namespace. And then this whole configuration section is completely different from what they recommended. There's Filebeat. The configuration for Filebeat is very versatile. So there's going to be more than one way to address this. So this is how I got it to work. For my environment, I'm saying hence enabled true, and then hence default config enabled false. So that's turning that off. Now on the deployment, here, the main thing here, if you go through the documentation, under annotations, Filebeat is going to be picking that up. So if you add this annotation, logs enabled true, that is overriding this. So here the container, I'm saying enable false, but on the individual ones where I want the logging, I set it to true. So that is how that is getting picked up. So Filebeat's going to be looking at everything. I'm hoping this makes sense. By default, logging is turned off. So logging is off on Filebeat. And then on specific containers, I'm using a annotation to enable it true. And one very easy mistake, there's a metadata section here for the deployment. Be sure that you are on the metadata section for the template. The template itself is going to be applied to the container that is running, and then the container will get these annotations picked up. So I had to add this data to each one of those. So this is configuration for Filebeat, to set up Filebeat. Adding that to the beer service, inventory failover, and order service. So I had to go through that, and then I redeployed those. Let me toggle over to the command line. Kube control get services, and we see here that we have the various services running. Important thing is Kibana. Remember, we set that up to be node port, and we can see that Kubernetes is going from the cluster port of 5601 to 31166. And now I'm going to come over here. All our services are running. Let's see here. Come back over to Chrome. And here I am on Filebeat. So you can see here I'm on 31166. And this is a log entry. And this is all the data that we are getting. And let's see here. So here's the message. So let's see, this from the order service. So we can see it's from order service. We have the logger, so that's the package name of the logger, the actual log message. So a number of things that we can see here. And then also you can see the trace span ID and also the trace ID. These are values that you can use to search on transactions go through. So these last two here, these are being added to the system by Spring Cloud Sleuth. So that this is a set of metadata that you can use to trace a call throughout the entire system. So something goes through the gateway into the beer service and then to the inventory service. You'll be able to use that trace ID to go ahead and look through that. I don't have a handy example to show you that, but it does work nicely if you need to trace something through multiple services. Again, that is Spring Cloud Sleuth that provides that data. So let's toggle back over to IntelliJ. And just to recap what we did, this is the Filebeat manifest. I modified it to the namespace of default. Use this configuration. So this is completely different from the example provided. So the Filebeat auto discover has been reconfigured. And basically what I'm saying is it's enabled true. And then the default is enabled to false. So by default, I'm not going to be looking at log data for Filebeat. And then here on each individual deployment, I'm using it under the template metadata annotations, the CO elastic logs / enabled true. So that is turning on Filebeat detection for this container. So any container that is pulled up, so even if I told Kubernetes I want 3 of them, all 3 of them would get picked up and have Filebeat logging enabled, and Filebeat would pick up the logs from that individual container and ship them to Elasticsearch, and then Kibana would pick those up. So these are the primary important pieces of the configuration to get Filebeat doing the consolidated logging for us, to log all the logs up to Elasticsearch so Kibana can search it for us. And here I'll be committing this into the GitHub repository so you guys will have a working example that you can pull from.